This is a quick resource I made on SolidWorks just to show students how a paraboloid is formed. So a paraboloid is formed by a cutting plane that is parallel to either side, one of the sides of the extreme generator. So in this case, it's the cutting plane is parallel to the left side of the extreme generator. So the cutting plane cuts in, and then there's always a focus sphere within it. So the focus sphere would be tangential to this cutting plane and at the same time tangential to the generators on the cone, as there is a multiple generators all coming down this cone to create the shape. So it would form a focal circle if we look at from the top. So sorry about that, but it would be a circle like this. So then if we go back to looking at it normal, that is the cutting plane. So the cutting plane is parallel, and to find the vortex is always going to be at the point between the intersection of the cutting plane and the extreme generator. So in this case we went across, and we're looking at an auxiliary because we want to see the true shape of the paraboloid, because the paraboloid is generated when a cutting plane cuts a cone parallel to either generator. So as we said, we find the vortex, and this is the vortex, and then the focal point is found by, if you go perpendicular to your cutting plane and through the center, that will find you your focal point. And now we need the directrix. So the directrix is found that there's a horizontal cutting plane that goes through that cuts through the section cut, which is this one here, and where they intersect is the directrix. So this will always be, the horizontal plane will always be horizontal, and the distance from V to F is always going to be the same distance as from F to D. So I would use this resource to show students what the cone looks like, and mainly to show that it's an auxiliary projection. So here we are, we'd measure this just to prove it to students. So here we know it's 39.41, and now if we go out of the sketch and we look at it as a true shape, so we're going to want to look at it like this, and if we measure it, so just get the measure. Measure there to there, 39.41 exactly. So if we just hover over it for you to see. So I'd use this resource as another tool to prove it to students that this is how a paraboloid is formed, and for them to visually see it, as I think it would aid their understanding.